G'day, I'm Eustace Black, author and all-round net fun guy. Welcome to the We Agnostics podcast. I may not believe in religion, but I believe in you.
Welcome to episode 8 of the We Agnostics podcast. Today I'd like to discuss some of the relationships between AA and what might be called the one single pill. So the approach really is one between the sort of tensions between the spiritualist approach of AA and what neuroscience and science and chemistry of the brain can tell us about addiction. So AA itself is not really opposed to medicine. One quote from the Big Book says, "Neither does AA take any particular medical point of view, although we cooperate widely with the men of medicine, sick, as well as with the men, sick, of religion." However, the most telling quote is probably from the Big Book on page 31 in the section more about alcoholism, which talks about physicians who are familiar with alcoholism agree there is no such thing as making a normal drinker out of an alcoholic. Science may one day accomplish this, but it hasn't done so yet. And you see, this is where we have to examine the time. What does that "yet" in that quote mean? If I think about these things objectively, really, if we're talking about the difference between 1939 and now, it's almost 80 years. If I was to refer that backwards, what are some of the differences between 1859 and 1939? Well, they're pretty much massive. Aeroplanes didn't exist. They were up and flying and commercially available, transporting people pretty much all over the world by 1939. We didn't have the tools for wiping ourselves out. Things like machine guns, trench warfare, chemical weapons were all invented between the period 1859 and 1939 and were in common usage. On the positive side, the development of X-rays and modern medicine. By 1939, antibiotics themselves were not far off either. We had understood that we developed as a species via evolution by natural selection in that period, 1859 to 1939. So we can see the changes are massive. Why then is AA stuck in 1939 in many cases? Why are people so dogmatic? Why are they not looking at the science of addiction and trying to use it to understand what's happening with alcoholics? There are medicines available now which were not available in 1939, like baclofen and naltrexone, which seems to be particularly useful when used in conjunction with the Sinclair method. So today I'd like to talk and look at an article that was published in The Atlantic in regards to medication and alcoholism, and I think there's some real hope in that article. So I'm going to go ahead and read it to you so you can have a listen. It'll be linked on the Twitter feed and on the Facebook page as well. So if you want to, you can go and have a read. A landmark study in the origins of alcoholism. By studying rats in a smarter way, scientists are learning something useful about why some drinkers become addicted and others don't. Only 15% of regular drinkers become dependent on alcohol. For Marcus Heilig, the years of dead ends were starting to grate. A seasoned psychologist, Heilig joined the National Institute of Health in 2004 with grand ambitions of finding new ways to treat addiction and alcoholism. It was the age of the neuroscience revolution, and all this new tech gave us many ways of manipulating animal brains, he recalls. By studying addictive behavior in laboratory rats and mice, he would pinpoint crucial genes, molecules, and brain regions that could be targeted to curtail the equivalent behaviors in people. It wasn't to be. The insights from rodent studies repeatedly proved irrelevant. Many researchers and pharmacological companies became disillusioned. "We cured alcoholism in every rat we tried," said Heilig, who was now at the Linköping University in Sweden. "At the end of every paper we wrote, this will lead to an exciting treatment. But everything we took from these animal models to the clinic failed. We needed to go back to the drawing board." Heilig does not buy that mice and rats have nothing to teach us about addiction. It's more that researchers have been studying them in the wrong way. Typically, they let the animals self-administer drugs by pressing a lever, which they always learn to do. That should have been a red flag. When humans regularly drink alcohol, only 15% or so become dependent on the stuff. Why them and not the other 85%? That is the crucial question, and you won't answer it with an experiment in which every rodent becomes addicted. Eric Orliger, who recently joined Heilig's team, tried a different approach, one pioneered in his former laboratory to study cocaine addiction. After training rats to self-administer alcohol, he offered them some sugary water too. This better mimics real life, in which drugs exist simultaneously with other pleasurable substances. Given a choice between booze and nectar, most rats chose the latter, but not all of them. Of the 32 rats that Orliger first studied, 4 ignored the sugar and kept on shooting themselves up with alcohol. 4 rats is laughable, said Heilig, referring to the study's small size. But 620 rats later, no one is laughing. Orliger repeated the experiment with more rats of various breeds, and he always got the same results. Consistently, 15% of them chose alcohol over sugar, the same number as the proportion of human drinkers who progressed to alcoholism. These alcohol-preferring rats showed other hallmarks of human addiction too. They spent more effort to get a sip of alcohol than their sugar-preferring peers, and they kept on drinking even when their booze supply was spiked with an intensely bitter chemical or paired with an electric shock. That was the striking thing to me as a clinician, said Heilig. Embedded in the criteria for diagnosing alcoholism is that people continue to take drugs despite good knowledge of the fact that they will harm or kill them. Many lab studies treat animals as if they were identical, and any variation in their behaviour is just unhelpful noise. But Orliger's work, the variation, is the important bit. It's what points to an interesting underlying biology. This is a really good study, said Michael Taff, a neuroscientist at Scripps Research Institute who studied drug addiction. Since only a minority of humans experience a transition to addiction, an approach such as this is most likely to identify the specific genetic variations that convey risk. This is exactly what the team did next. They compared the alcohol-preferring and sugar-preferring rats and looked for differences in their genes that were active in their brains. They focused on 6 regions that they thought were involved in addiction, and they found no differences in 5. But in the 6th, we did, said Heilig, and it made me smile, because I started out doing my PhD on the amygdala. The amygdala is an almond-shaped region that sits deep in the brain and is heavily involved in processing emotions. When Orliger looked at the amygdala of alcoholic rats, he found signs of unusually low activity in several genes, all of which are linked with the chemical GABA. GABA is a molecule red light. Certain neurons make and release it to stop their neighbours from firing. Once that's done, the GABA-making neurons use an enzyme called GAT3 to pump the molecule back into themselves, so they can reuse it. But the amygdala of the alcohol-preferring rats, the gene that makes the GAT3, is less active and makes just half the usual levels of the pump. GABA accumulates around the neighbouring neurons, making them abnormally inactive. The consequences of this are unclear, but Heilig thinks that this extra GABA hampers the rat's ability to deal with fear and stress. They naturally are more anxious, which might explain their vulnerability to alcohol. He predicts it will take another 5 years of work to fully close this loop, but for now his team definitely show that GAT3, the GABA recycling pump, is important. They took rats that prefer sugar and deliberately reduced the levels of GAT3 in their amygdala. This simple procedure was enough to convert these resilient rodents into alcohol-preferring, addiction-prone 15%ers. At this point, the team submitted their results to a journal, which agreed to publish them. Good news! But after Heilig's long history with rat-shaped dead ends, he wanted to do one more experiment. Curing alcoholism in rats is not important, he said. What's important is what it looks like in humans with alcohol addiction. As it happens, it looked much the same. Heilig's colleagues examined post-mortem tissue samples from people who donated their brains to research, some of whom had alcohol addiction. In the rats, they found nothing unusual in 5 of the 6 brain regions, but in the amygdala, they found low levels of GAT3. It was the same in the humans. Other scientists have found connections between alcoholism, the amygdala, and the GABA-related genes. But identifying rats that have particularly vulnerable to alcoholism, Heilig's team have begun fleshing out the details behind those somewhat hazy links. It is a very significant study that will impact the alcohol research field deeply, says Jun Wang from Texas A&M University. Identifying GAT3 is not that important because alcoholism is controlled by multiple genes, but the team's new approach will help find those genes It's a wonderful method for modelling human alcoholism. There are other signs that what Heilig found is relevant to humans as well as rats. A decade ago, a French cardiologist named Olivier Amilson claimed to have cured his own alcoholism by taking the drug baclofen. That was met with scepticism, but there was no basic science to support his claims, says Heilig. But there is now. Baclofen stops neurons from releasing GABA. If individuals with alcoholism aren't good at recycling this chemical, it might be possible to compensate by producing less of it in the first place. But baclofen is controversial. It has been tested in several clinical trials with mixed results. 2 recent studies which analysed the results of these trials concluded that the drug's ability to treat alcoholism is only slightly above placebo effects, and its growing use is premature. It might be harmful too. People quickly build up a tolerance to it, which prompts them to seek higher doses. They can experience severe side effects. And France has seen more than 100 cases of people inadvertently poisoning themselves with baclofen. It's a terrible drug, Heilig says. Other drugs like benzodiazepines also exert their effects through GABA, but like baclofen, they are easily abused themselves. They're a good alternative for alcoholism in the short term, but they are not safe in the long term, says Laura Ray from UCLA. But Heilig's study suggests that other chemicals, which could influence GABA levels in more subtle ways, might help people control their addictions. Several such substances are in development, and Heilig's team can see if they can change the choices of their alcohol-preferring rats. This is such an impressive breakthrough for the field of alcoholism, it has real potential for therapies, Ray adds.
You can now follow us on Twitter at WeAgnosticspod or email us at weagnosticspod@gmail.com. We also have a secret Facebook group. Email me for the details.
Thank you for listening to the We Agnostics podcast. Remember, stay sober, go to meetings, and take care of each other and yourself.